This is Mr. Bari from Columbia University.
This is Rev Bari from Brown University.
And this is New York University from Suborno, Bari.
Is that English?
No.
Okay.
I don't think he can do it.
Shut up! Get out!
Okay, so no, I thought I was the one knowing English.
God dang it! I thought I was the one knowing English.
It's like
We'll make so many grammar errors we just take it for granted now. Like we have an automatic translator in our head.
it's like your picture, right? Learning. Okay. So today our topic is all right. So today our topic is inclined plane. I did not tell this to losers ahead of time, so I just wanted to see their skill check. All right. So. Okay, good. So what is this one? Ref.
Gravity.
FG more precise. FG has how many components, Isaac?
Well, axis system we're using, which is parallel to the plane, is the x-axis, and perpendicular to the plane is the y-axis. It has two, of course. One parallel, one perpendicular.
Okay, good. So.
Okay.
All right. So what are we gonna call this one?
FG perpendicular.
And what are you gonna please both brother be on the camera? Okay. And what should we call this one?
FG parallel.
Okay. Now, what is this angle?
90.
Wow, I didn't know that.
And
congratulations.
What is this angle?
90 minus theta.
All right. Now, if you have, okay, so this is line 1, line 2, right? Two parallel lines cut by a transversal.
Right.
What this angle and this angle? What do you call them, Isaac?
There are alternate.
Oh, please don't block. Please don't block. Yeah, alternate.
I think he forgot. I'll help him. Alternate interior angle.
Alternate interior angle are.
I just know they're congruent.
All right. So alternate interior angle are congruent. Okay.
Kindly don't be an A for 1 second.
Okay. So if that is so, then if this one is A, which one is B?
Oh, that's a good question. Wait.
No, don't block.
That's a good question.
I think it's this one.
Yes.
Wait, Mama, my marker is literally an
Okay, hold
eraser.
on. So this is.
I think.
This is what? This is B, right? This is 90 minus A.
Yeah.
Isaac, if this one is A, which one is B? Without moving.
Without moving, I'm not sure. I'd have to move.
Yeah.
What do you mean? Which one is B? Like
this one is B.
That you can barely even see that, huh? But yeah. That's acceptable because, of course, you have.
No, go more.
You have the line that makes up this right edge.
Nobody see that. Go more.
You have the line that makes up the right edge of the inclined plane, and then, of course, you have gravity, which is parallel to it. Which means since we have two parallel lines and two other parallel lines, well, not exactly parallel, but.
I can draw it if you don't. Okay, no. If you understand.
Okay, that's fine. Okay.
Wait. Oh, yeah. Okay. I might be stupid. Sorry. Okay, so, I mean, we have.
You are blocking.
We have FG parallel, which is, of course, parallel to the plane of this ramp right over here. And so that means that we have regular FG going down this way, and we're trying to find this angle right over here. Of course, since this is parallel to that, and this is parallel to, wait.
No, these are the two.
Okay. I'm sorry.
No, it's okay.
Yeah, I'm genuinely.
I think you're right. No, I think you're right.
These two are parallel, which means that
so these are the two alternate interior angles. Yeah, yeah.
genuinely forgetting so much.
That's it. That's it. This is. I think that's all you needed to show.
What do you mean? I think. Yeah, this is correct.
Yeah.
Okay. So whose two lines are parallel? Is this one? This one parallel
this
is what?
one.
Isaac, can you make it
This
orange?
is-
No. Can you make this line orange?
This line right
If you
over
want
here
red.
is parallel to FG.
Okay.
That's
Can you
right.
make this one orange? No, no, don't erase it.
It's gonna be.
Okay. Who cares? The line doesn't have feelings. Okay. So now we're gonna have to discover what this is. Which one is 90? This, and this. This one is 90, right?
Yeah, which means that's.
So
Oh,
if this
that's
is
the
30 degree,
okay.
if this is 30 degree, this is
30,
if this is 20, this is
20.
all right. So then we're gonna use SOHCAHTOA. So maybe so and ka. So sine theta is equal to opposite over hypotenuse. So sine theta is equal to what is opposite?
FG parallel.
Okay, so FG parallel, right?
Mhm.
So I move it over here. FG parallel.
Parallel.
So opposite is FG parallel,
Mhm.
and hypotenuse is
FG.
FG.
all right. So then FG parallel is
FG parallel is FG sine theta.
FG sine theta.
Yeah.
Okay, now ka. So to do the ka, how do you CAH?
Yeah.
So cosine theta is equal to Jason. What is Jason?
Jason is in
FG perpendicular.
FG perpendicular and hypotenuse
FG.
Which means FG perpendicular is equal to MG cosine theta.
FG cosine theta. All right. This is one proof. Isaac, you do your own proof.
What are we doing?
Proving that FG perpendicular and FG parallel are these two.
Okay.
Oh, 1 second. I am not ready. I have to give you the mic. And 1 second. Is this my phone? 314. 159. Oh, 1 second.
Yeah, it's probably mine. 314159.
Okay, Isaac, 1 second. I have to put like.
I'm so tired.
This is the last one.
And then we can do physics here. Oh.
No physics.
I'm going to throw this. I don't even have that.
Oh, I don't know the password.
No,
Freaking dumb.
Oh no, that is something
Oh.
not safe.
Okay. Okay. All right. I'm not gonna give live.
Is it logged out?
I'm gonna not give live. I'm not gonna give.
No, it's long. Why should you have any reason to end me?
So you're gonna be behind the camera, record it. I'm gonna put it in charge.
Okay.
Okay, Isaac, you go. You have mic. Okay, go ahead.
Okay, so here's our own proof that FG parallel is equal to
Let's watch some of this.
and FG perpendicular is equal to FG sine theta. So first of all we have to do is just rotate our view like we're looking at it on a phone
Oh, I see.
to get something like this.
It takes a real genius to figure that out.
So this is what we're working with right now. So then, I mean, what are the two components that we're supposed to be decomposing this into? Well, these two.
Isaac, this is not the best color.
Do I have to redo the whole
No, you don't.
thing? So that means that if we rotate our view,
Yeah, don't block it.
we get something like this.
Something.
And of course, what are the two components that we're looking at?
FG is supposed to be straight down. Why is it like that?
We're rotating our view.
Oh,
Okay.
so write it down then. Rotate our view.
How much did he rotate by?
I mean, theta in this direction, the anti-clockwise.
And what was your center of rotation?
The center of rotation is just assumed to be the center. the center of the hypotenuse of the ramp.
Okay.
Is this?
But the center of rotation is basically irrelevant because you can just translate or drag around your view.
I see.
It doesn't even matter at the end of the day. Okay, so rotating our view.
1 second. Can you tell the audience what are you doing actually?
Yeah, we're proving that FG parallel is equal to FG cosine theta. FG perpendicular is equal to FG sine theta. So then what are our two components? Well, this is FG perpendicular and this is FG parallel. So then, we just have a right triangle over here. So what is FG perpendicular? Well, let's introduce a new angle and we'll call this angle right over here alpha. So then, what's FG perpendicular? It's equal to FG sine alpha. And then, what's FG parallel? That's equal to FG cosine alpha. Oh, I have a feeling I switched these up accidentally. Okay, so how do we connect alpha to this theta right over here? Well, we can actually do something very... There's basically only one proof of this thing because it's something so simple.
I think so.
No, actually, I have a different proof.
No, please stop. You do not have a different proof.
Okay.
And we all know that. So,
ignorance is the benefit of the believer.
We have this right over here, and then we have the object right over here with FG cutting in this way, and of course FG perpendicular and FG parallel pointing in those ways. So then, given these two, how are we supposed to figure out this angle in relation to theta? Now, this might be the most convoluted proof you've seen in ages, but just stick with me. So, of course, since FG is perpendicular to the bottom of the ramp, that means we have this right over here, and we have this angle over here, which is 90 minus theta. Now, we know that this is the ramp's plane, and this is FG parallel, which has to be parallel to the plane of the ramp, which means we have two parallel lines and a line going between the two of them, which means we can use the alternate interior angles thing and say that alpha is equal to 90 minus theta. But sine of 90 minus theta is equal to cosine of theta. And likewise, cosine of 90 minus theta is equal to sine of theta. Which means that all we have to do is just plug that into that and get that FG perpendicular is FG cosine theta and FG parallel is FG sine theta. This is basically just that proof, but way more inefficient.
I have a much better proof.
Show it to us then.
But it is too big to fit in the margins of the paper, of the whiteboard.
Bro thinks he's Fermat.
Yeah.
Okay, go.
Bro thinks he's Fermat.
Okay.
Bro finna leave this an unsolved problem.
He's not Fermat. He is next Sir Isaac Newton.
Einstein.
You don't insult my...
Albert!
You don't insult my Sir Isaac Newton.
You don't insult my Sir Isaac Newton. Acting as if you met the guy.
What do you mean I met the guy?
Not a single one of your direct ancestors has ever come within 300 miles of Sir Isaac Newton's direct ancestors. So do not speak.
How did you end up getting Isaac in as middle name?
Most people see physics. I see mistakes. Okay, I'm joking.
Most people see Rifat Bari. I see mistakes.
Okay. Okay. So here's my proof.
Hold on 1 second.
Yeah.
I'm not ready.
I wasn't ready! I'm so messed up. I'm tired.
Isaac, that's it.
Am I free?
If you can find one mistake,
Can I go?
try to find one
No,
mistake.
try to
and
find.
then
You
prove-
sit down. You sit down. You don't have to.
No,
No, you cannot go anywhere because you have to
I
change
just
the
find-
dress. So sit over here for 2 minutes. Oh, by the way,
It's that good.
can you imagine you using phone? Okay.
You're trying to find one
Do
mistake.
I have to do research after this?
No. Look at me and explain what you want to do.
Okay.
You're not gonna be mumbling for half an hour.
Yes, you will. And so that's how it connects to the derivation of E equals mc squared and the Finalizing principle. All you have to do is take the path integral of s over the entire inclined plane, and then 30 steps later, 2 hours later. Oh my god, I can't do this anymore. That connects to how we derive the Ampere-Maxwell law.
Alright, Isaac, enough.
I need a second.
Is he roasting me or you?
I don't know.
Huh?
I don't know.
Okay. Or you killing two birds in one stone.
No, him.
Okay. Okay.
Alright.
So, hello folks, this is Rev Bari from Brown University. Today I'm going to show you.
Know that.
So today I'm going to show you why FG parallel is FG sine theta and FG perpendicular is FG cosine theta.
As your predecessor.
My great overlord. How does this connect to the derivation of f equals kx?
Okay, I'll show you. So, okay. So first of all, these are just equations, but what is the picture behind?
Oh, I thought they're candies.
No.
Me personally, how does this connect to the derivation of E equals mc?
So,
Refast is one of a kind.
For me and Rev, everything is F equal ma. The
So-
only reason you know God exists is because F equal ma is so beautiful.
Oh, you're gonna go into that rant that you did in the other video, right?
okay. So let's take a look. So this is an inclined plane, and
Oh my god!
Okay.
Me personally, I thought it was a taxi.
Okay, great.
Oh my god, that's not a right angle. That's
Okay.
60 degrees.
Okay, sure. So this is an inclined plane. Yeah. Okay, great. Okay, great. So this is an inclined plane, and we have a box on our inclined
You
plane.
sure that's a box?
Okay. Relax. Okay.
It looked like a
And-
demon egg.
So gravity is always acting straight down on the box. Now, this inclined plane is inclined at an angle of theta. What we want to show is that when we decompose this gravity vector into a parallel component, FG parallel, and a perpendicular component, FG perpendicular, they're related to the original gravity vector by these two
Blue
equations.
And red?
So
like-
FG parallel is equal to FG sine theta, and FG perpendicular is equal to FG cosine theta. So we have to prove that this is true. Okay, so how do we prove this? So,
Stalling for time, I see.
no,
So we have to prove that this is true. So how do we prove this? We prove this.
okay,
By
great.
proving them.
So if you look at this two, it's very easy to forget
This
which
two?
one is sine theta, which one is cosine
What
theta.
the?
Can you
This
do
is the
that?
way he covers it up. This is how he covers it up. FG parallel is sine, FG perpendicular is cosine.
No. So
What do you mean no?
can I show my proof?
You don't just
So-
say no.
Many times I think that this is cosine theta and this is sine theta.
Yeah, because there's two fish.
No, just relax, okay?
You have the memory of a goldfish.
So how do we know which one has sine theta, which one has cosine theta, without going through the full derivation? It turns out there's a very simple physics way to figure it out, and that's by using limiting cases. So here's what I mean. Imagine you have a ramp that has theta that is very close to 90 degrees. So imagine you have first a very low ramp, okay? Then you have a slightly steeper ramp. then a slightly steeper ramp, then an even more steeper ramp, and then
Even
a ramp,
more steeper?
a ramp that is almost 90 degrees. If you have a ramp that is almost 90 degrees, then the box should almost be in free fall. That means gravity should be acting. Which component of gravity should be bigger? FG parallel or FG perpendicular?
FG parallel.
FG parallel should be bigger if theta is almost 90, right? If theta is almost 90,
I find theta is almost 0 to be easier.
If theta is almost 90, then FG parallel should be much bigger than FG perpendicular, right? Because the box will almost be in free fall, right? And if theta is exactly 90, then there is no perpendicular component. Think about it. Let me draw the picture again. The first time you see this argument, it might be kind of look like magic. So let me show you again. So here is the inclined plane. Okay, let's say this is 30 degrees. Theta is 30 degrees. Okay, so
By the way, this isn't conclusive proof.
Here's the box.
You're assuming. Okay.
Okay. Can I get the criticism after the proof? After the proof. Show the criticism after the proof.
Someone help me. You're already assuming that FG parallel is equal to FG trig theta.
That's what I'm assuming. Okay.
I mean, that's
okay,
not a...
This is a physics proof. Okay.
It's not a very good one.
Okay, yeah.
It's already assuming half the problem.
Okay, sit down. Okay, I know you like to find mistakes when there's no mistakes to be found.
Huh?
So, take a seat. Please take a seat. Okay. So let's start with theta equals 10 degrees. Then theta equals 30 degrees. Then theta is 45 degrees. Then theta is 80 degrees.
Everything with respect to x-axis, right?
That's right.
Theta is with respect to x-axis.
No, it's
Everything
with respect to the z-axis.
Everything with respect to x-axis. Okay, can we sit down?
Definite.
Please sit down. Okay.
I don't even have the energy to fight back.
Okay, theta is 80 degrees. And theta is 90 degrees.
With respect to x-axis, right?
That's right, with respect to the x. Yeah. And here is our box.
Box is with respect to x-axis.
Oh my god, I thought it was with respect to the fourth dimensional W axis.
You're rushing me out of there.
You!
Okay.
Obviously.
Okay, so remember gravity is always acting down, right?
I thought it was acting up.
Well, I mean, I know why you would.
The only person acting up is you.
Okay, so see, this is gravity. Gravity is always acting straight down. Now let's break up gravity into the two components, into FG parallel. FG parallel and FG perpendicular. Okay, FG parallel, FG perpendicular.
But now this time perpendicular, not with respect to x-axis. You have to say that with respect to the box.
Oh my goodness! I thought it was with respect to me. Does nobody respect me in here?
Yeah. So this is FG parallel. Okay.
If everything had a proof in that one, that would be great.
Unfortunately, that will never happen.
Okay, so what do you notice as theta is increasing? Which one is getting bigger? Which one is getting smaller?
As theta increasing, sine or cosine getting better, bigger.
No, which component is getting bigger?
Getting way bigger. And sine.
Okay, no, I want that.
So parallel one at 90 degrees 100%, at 0 degree is 0%, and vice versa.
Yeah. So you can see FG parallel.
So put a 0 degree one, put a table, put the box on the table.
Okay.
Put 0 degree one.
It's flat.
Yeah.
The theta is 0 degree with respect to x-axis.
Yeah. And so gravity is acting down, and FG perpendicular is this one, and this is FG parallel.
What is FG parallel? There is.
No, it's not really there. I just drew it so people can So FG, so you can see FG perpendicular is very big.
So now can you put the can you put the value? Okay, so put the value over here. Draw a line so we're gonna tell the value. So 0.
Mm-hmm.
Alright, so the first one is 0.
Here.
Yeah.
Okay.
And the last one is 1. Last one.
Let's say 100. Yeah, let's say 100. Okay. And this one?
Last one at 100.
Okay.
Last one is 0.
0. Actually, let's say 1 for a reason I will say later.
Yeah.
Okay. Okay. Let's make up numbers. You see FG.
Why making up numbers? G sin theta.
No. We don't know which one is sine, which one is cosine.
Okay. Isaac is better in
Okay.
faking things.
Oh shit! Wow. I didn't expect to have to say that.
Yeah, but you're the best in faking expertise.
Okay. So let's calm down.
He's very precise.
Okay. Yeah, I know it takes a lot of thinking to come up with random numbers.
Shut up!
No, please.
Oh crap! Sorry. I'm wrong here.
Okay. Okay, great.
No. Shut.
Doesn't have to be accurate.
That's why you never put him on a spotlight.
Yeah.
He will steal it.
Okay, great. Okay, let's go back to where you.
Okay, there we go.
Okay, let's go. Thank you for your negligible input. Okay, so. Okay, so.
You're more negligible than air resistant. So don't talk.
Negligible? Okay.
Negligible.
Okay. So the main question is we don't know if we know they're both FG, right? But we don't know if this is cosine theta or sine theta. And
You
we
don't
know
know.
if this is
I know.
or this is cosine theta or sine theta. Now, which one is going okay, yeah. Now, if you look at our diagram here, as theta is increasing from 0 to 90, you see that FG parallel is increasing from 0 to 1. So
is this a math proof or visual proof?
No, it's a limiting cases proof.
Oh,
so
It's
yeah.
It's a BS proof. It's already assuming that it's a trig function.
No, which one increases as theta goes to 90?
Tan of theta.
Okay, can you not? Cosine doesn't increase as theta goes to 90. Cosine goes to 0. That means FG parallel must be sine theta.
That's true.
And then you can use the same argument for FG perpendicular. Which one goes to 0 as theta goes to 90? Is it cosine or sine? When theta becomes 90, does cosine or sine become 0?
Cosine.
Cosine. That means FG perpendicular must be cosine theta.
Yeah, but also
FG perpendicular is FG cosine theta, and FG parallel must be FG sine theta.
Okay,
so that's the proof.
Yeah, but this doesn't prove much. Like
another way you can
wait, no. Can you let me?
No, another way you can prove it is x is usually cosine theta. So this is just opposite, sine theta.
I mean, for all I know, it could be this is FG parallel and this is FG perpendicular. It doesn't have to be this is FG parallel and this is FG perpendicular.
What are you talking? What are you drawing? What are the axes?
Okay,
Now you erased your whole bogus graph.
Shut up!
Jesus, scary guy.
Okay, so I mean, you know how? So this is just theta, and this is the force, the magnitude of the force, right? So I mean, you're claiming that because we know it's going to be 0 at 0 and 1 at 1, it has to be like this, where this is of course at 0.
Yeah, because you know that it has to be a trigonometric function of theta.
How?
What else would it be? I mean, you always assume
Could be this.
No, if it's that, no.
Could be this.
No, it literally can't, because you can take the halfway case. In the halfway case, they must be the same. So that's a limiting. So you know it has to be sine theta or cosine theta because those are the only trigonometric functions that are equal at 45. You can't argue with that.
That's right. My ref is right.
Okay.
There's no way you can argue with that.
Yes, I can.
There's no interpolation that's equal at pi over 4 that's not sine theta cosine theta.
And how can Brown be?
Wait, why would that? Okay. Okay.
Yeah.
Now look at this. Look at this.
This is low-hanging fruit.
Let's see. So this is sine. Is this sine or cosine? I don't remember. Actually.
Are you stupid? That's sine.
Oh, that's sine.
Starts at 0.
And this is
Cosine.
cosine. So they're equal at 45, right?
Yeah. And so this.
No, but if you take you can look at it another way because you can take the first derivative.
He is so desperate.
You can take the first derivative. So this is just f.
First derivative. No one's going that far.
So this is cosine theta. If you take the first derivative of these constants, they just vanish. But you know that the first derivative has to be slowing down because you're approaching the maximum value. So in either case, as you approach pi over 2, you have to be
Still, you could just use like an interpolating parabola or
but
whatever.
now you're just
this
making
doesn't
it.
prove
Now
anything.
you're just making it more complicated.
No, what you're doing doesn't prove anything.
In physics, it's always the simplest possible answer.
You're not proving anything.
No, I just proved it has to be sine theta and cosine theta.
Yeah, but that's with the assumption that it's trig theta in the first place.
But that's what you're saying. I can't make.
You have to first prove that and then prove this.
You don't have to prove it.
This is half a proof.
This is.
You're presenting me with half. You're presenting me with a half-eaten bagel
Okay.
that you just spat on as well
Why are you reluctant to give him credit?
and been molding for the past week.
Well,
Is anyone
then let's
really
talk
gonna
about
eat that?
your proof.
Yeah, how was my proof so bad? Huh?
Well, there was no proof.
There was a
There
proof.
was no proof.
No,
You just copied
he
that.
said 90 minus theta is sine theta.
Yeah.
Sine.
What?
No,
No.
his proof was. This is your proof in a nutshell. Assume FG perpendicular is this.
No, I didn't.
Therefore, we proved it.
Huh? Huh? You're lying on my name, you fat freak.
Okay. I concede that you're
better.
that I'm
Okay,
better.
we should have a Nobel Prize before you.
Well, I wish you field medal before me because I'm not even in that field.
I wish that absolutely nothing worthwhile happens in your life.
God, that's dark. That's really dark.
And I also wish that nothing bad happens to you, so you just end up living a lackluster life
Oh, God.
without any flair.
Wow.
And you die with no stories to tell.
Oh my God. This guy is evil.